Good evening. Welcome to the latest weather discussion on our storm that is moving through the region. It's January 9th, 2024. It is currently 6:40 p.m. and we have a lot to talk about as we study this dynamic storm. So here is the latest observations. You can see winds coming in from the southeast very strongly. Everyone's above freezing now, so everyone, including the Poconos and the Catskills, are experiencing rain. Heavy rain at that, with temperatures ranging from the mid to upper 30s in northern Connecticut and around the Catskills and Poconos, mid to upper 40s in your northern suburbs in New York City, and lower to mid 50s down towards southern New Jersey. You can see our warm front pushing northward with the strong southeasterly winds ranging anywhere from 10 to 20 miles per hour at times, pushing up to 30 miles per hour. And take a look at our radar here. You can see there's our warm front, very heavy rainfall, and just a wave after wave of rainfall moving into the region here. You can see when we actually move it here. There it is. And again, this is on WeatherTap, just so everyone knows. We have a warm front again pushing northward. Back here is our cold front. We're waiting for this area of rainfall to march its way through the region. So I'm going to pause this. What we have is a lot of interesting observations. So earlier on, we had snowfall ranging anywhere from 2.8 inches in the Poconos, 1.8 inches in Mount Cobb, 2 inches in Wayne, Pennsylvania by Beach Lake. So there's our 1 to 3 inches that we were looking for, clearly developed. Now we're seeing the winds. We haven't gotten flood warnings yet and flood observations around our neck of the woods. Down towards Maryland, we've seen some flooding, but we've certainly seen our increase in wind gusts. We haven't even seen the bulk of the strong winds yet. We're already seeing down trees around I-295, which is a major highway around the region, around Burlington and Mount Holly. We've seen another wind gust just in northwest South Brunswick, which is again another area where we have a lot of traffic. Reported trees down. And here's the thing, with the soil being so saturated and you're adding rain and then you have the strong winds, it allows for these trees to basically lose their hold to the ground, and it allows them to tip over and fall over because the ground is so saturated. And we still have a lot more rain to go before we get done with this rainfall. Now, I want to show you a couple of images here from the SPC, and this is some really cool data. So we're kind of get into the technical stuff here. So we're going to start at the top of the atmosphere. And remember what I talked about in the videos this morning, where you have that divergence and diffluence and that stretching of the atmosphere. Well, you see this is 300 millibars, heights and a geostrophic winds. And essentially, when you start to get a lot of lifting and a lot of divergence and diffluence, you start to get these areas of ageostrophic wind allowing for that stretching in the atmosphere to develop. So when you start to see this signal here, that means that air is rapidly rising. Go down a little bit further in the atmosphere. Let's take a look at 700 to 400 millibar differential vorticity advection. Again, this is another sign of rising, twisting air. And again, there's your divergence and diffluence, and there's your waves of strong lifting associated. Now, remember, with strong lifting, there's also subsidence, sinking air. So you have one area of strong PVA here, another strong area of PVA over here, a little bit of sinking here, more strong PVA here. And that's how you start getting your waves of moderate to heavy rainfall and then some pockets of lighter rainfall as the air continues to rise and sink. Meanwhile, in terms of frontogenesis, you can see here's our surface warm front here. Here's the 850 millibar warm front here. So you can see waves of warm air moving northward. And let's see, another aspect to take a look at is a deep moisture convergence all over the northern mid-Atlantic. So this means at the lower levels, you have moisture converging and lifting. So this is going to support a lot of rising air. And then the transport, well, there is your strong moisture transport that we've been talking about. Now, what causes this strong moisture transport? Well, let's take a look at 850 millibar winds. And here is the big deal here. These strong winds at the mid levels of the atmosphere are starting to get mixed down. And these are very impressive winds. We're talking about 80 knots, potentially pushing up to 90 knots. We're seeing the observations already supporting that in many locations. So again, very strong gesture. You can transport a ton of moisture northward and allows for the strong winds to mix down. And what's a concern here is that when we take a look at the SKU-T chart, which we got from Tropical Tidbits, so you could totally check that out. It's completely free. Great data. This is on the HRR guidance, and you can see this slight area of instability right here. And this slight signal here after an inversion supports the potential here for some elevated thunderstorms and a squall line within this heavy rain band, which is a concern. So you have a saturated atmosphere, and then you get that little bit of lifting here that takes place. And the reason why that's important is because you have all these strong winds here. So what happens is that this parcel of air rises, it gets mixed, and takes some of the momentum of these winds and takes it down to the surface again. So that's essentially what is happening here. Parcel of air is getting lifted. It reaches a point of condensation and it reaches a point where that convection allows for mixing and brings the momentum of this air that's moving back down towards the surface. And that is essentially what produces your wind gusts. On the infrared satellite picture, again, incredibly impressive, very strong lifting. Remember, the colder the cloud tops, the stronger the lifting. And we got plenty of lifting here on the upper level winds. Here's our divergence and diffluence again, just textbook phased storm. Only problem is for you snow lovers is that it's in the middle of the Great Lakes rather than off the mid-Atlantic coast, and that's why we're seeing waves of rainfall. And the water vapor satellite picture is just, it's destructive, but it's, to me, it's art. You know, this is just amazing. The moisture transport we're seeing here. You hear a lot in the news about atmospheric rivers. Well, this is one. Let's take a look. Let's go all the way back. The river starts down here, and you can see it getting pulled northward. You can see some connection from the Pacific here, cutting across Mexico, through the Gulf of Mexico, through the Northern Caribbean, and right up the East Coast. Now, if that is an atmospheric river, I mean, wow, that's impressive. So all of that moisture is just getting drawn northward and getting lifted by this strong upper level low as it marches towards the region. And so on the latest HRR guidance, you can see just waves of heavy rainfall continuing tonight. There's our squall line marching through later on tonight after midnight, swinging on through. By tomorrow morning, we start to clear out. The worst of the rainfall will be over, but we'll still be dealing with strong wind gusts. And you can see here, the wind gusts here at 10 p.m., we're talking about 50 to 60 mile per hour winds, possibly 70 mile per hour winds on the coast. I think the 70 mile per hour winds will be more isolated. And again, this is just swinging on through with the worst conditions on through about 2 a.m. And then we start to improve from west to east, but still going to be breezy. Tomorrow will be drier, but it'll still be pretty windy out there with winds ranging from 20 to 40 miles per hour and sustained winds at 10 to 20 miles per hour. That is your latest update. We will be back later on as we're sending out all the rest of the updates throughout the evening as we normally do. So please stay safe out there, stay indoors, and continue to keep an eye at nynjpaweather.com.